Now, we are going to present our group project, Marketing Campaign Analytics. This project focuses on using business analytics to support data-driven decision making. Business analytics help organizations understand customer behavior, optimize operations, and gain competitive advantages using descriptive, predictive, and prescriptive analytics. In the context of marketing campaigns, customers respond vary across products, demographics, and promotion types. Therefore, analytics is essential to identify which campaigns are truly effective. The objective of this project is to analyze marketing campaign data using exploratory analysis, data modeling, and predictive analytics, and finally generate data-driven recommendations to support executive decision making.
Hi there. I am the Task 1 lead. I will be presenting the exploratory data analysis for our marketing campaign project. My goal was to investigate 2,469 households across multiple proportional campaigns. I was looking at determining effective campaign types, identifying product purchase frequencies, understanding coupon response patterns. So this exploratory data analysis serves as the data-driven foundation for subsequent modeling and predictive tasks. So we integrated 7 rational tables via our studio. To ensure data integrity, we performed a strict cleaning protocol, removing zero value sales and administratives known as missed categories to focus purely on actual customer behavior. So we had a few assumptions. First of all, we assumed on the higher coupon redemption rates that indicate stronger engagement and that transactions without coupons serve as our organic non-promotional baselines. And more as we integrated heat map. So the color intensity is also used as a proxy or like a what do you call it indicator for sales concentration and behavior peaks. So we will move on to the visuals. So for the first one is based on campaign effectiveness. This is visual 1 and 2. So these show that the campaign type A is our highest grossing strategy. A key insight here is that the extreme price sensitivity is in the grocery department. The revenue actually spikes are almost entirely dependent on the depth of the discount that is offered. So the next we'll focus on product demand velocity. We're using 2 visuals, which are product frequency, the most and the least. So on here, this is visual, what do you call it, 3 and 4. So fuels and staples like milk drive the food traffic. So while niche items like toys and many more show very low demand, these important items are our anchors for pulling customers into the store. So let's talk about visual 5, coupon popularity based on this visual. We get to know that the grocery redemption overthrows all other categories. This confirms that our customers use promotions to lower their daily cost of living rather than for luxury impulse buys. Let's focus on buyer segmentation. We're using 2 visuals, which are customer sweet spot and even brand behavior. So basically, we found that national brand sales are nearly double those of private labels during campaigns. Our sweet spot demographic actually shows that 35 to 54-year-old bracket with a mid to high income range. That's the sweet spot for this campaign. Let's focus on household and timing. So visuals 8 and 9, as we can see here, it's shows that actually small households lead in total sales, and there's a consistent 3 to 5 day lag between campaign launch and the peak sales, proving our customers are planners and who wait for the weekend. Okay, finally, we're on operational timing, also known as the weekday peaks. So this visual actually confirms that Sunday is the peak shopping day. They can launch campaigns earlier in the week to capture this weekend volume surge when customers execute the what do you call it shopping plans. Okay, my 3 final recommendation based on the task that I've done is that first they have to relocate the budget for type A to type A, and then the target should be more focused on 35 to 54 years old demographic, and the third and final, which they should optimize to launch windows for weekend peaks. And that's all from me. Thank you.
For task 2, we focus on multi-dimensional modeling using the complete journey dataset. The main objective of this task is to design and implement a data warehouse that supports sales performance analysis. The analytical perspective includes product, promotion, transition, and time, which allow us to view the data from multiple business angles. This dataset is provided in ARM-native formats such as .rda and .rds, so we use Python with the py readout library to extract and process this file into pandas data frame. The main file used are transition sample, product, campaign description, coupon, and coupon description. This dataset together support multi-dimensional sales analysis. For the warehouse design, we select a star schema. This because star schema simplify analytical query, enable fast execution, and is well supported by the BI tools like the above. The design consists of one center fact table, fact sales, surrounded by multiple dimension tables such as time, product, transition, and promotion. This structure allows sales measure to be analyzed efficiently from different perspectives. Next, We implement the ETL process, which consists of extract, transform, and load. For extract, we load the out native file using the py readout and convert it into the pandas data frame. For transform, we convert the type string into that type format, create type adjectives such as month, week, day, and part of day. Build dimension table, generate a style key, and link all records to form the fact table. For load or transform, the table will export into an Excel workbook, with each table stored in a spreadsheet. This makes the warehouse easy to use in table. For one-dimensional analysis, we can compare sales amount by department, sales quantity by part of day, sales amount by campaign type. This chart analyzes sales using only one dimension at a time and giving a clear overview of individual factors. For two-dimensional analysis, we can compare sales amount by month and part of day, sales amount by week and department. These visualizations allow us to analyze the relationship between two dimensions similarly using the heat map. For multi-dimensional analysis, we create heat map of sales amount by month and department and filter by different campaign types such as campaign none, campaign A, campaign B, and campaign C. This demonstrates the size and dice capability of the data warehouse, where user can dynamically explore sales pattern based on multiple dimensions. Next, I will pass to my group member to present.
I will present the task tree, which is the customer churn prediction. The objective of task tree is choose a set of suitable data to perform predictive analytics and compare with three different machine learning algorithms. After analysis, the transaction dataset and demographic dataset is chosen. These datasets were chosen because churn is inherently defined by purchase-in activity, which can only be derived from transactional data, while demographic attributes help explain behavioral difference among the customers. This is the confusion matrix of the logistic regression. We can see the accuracy, precision, and the recall of the model. And this is the evaluation of the decision tree. And lastly, this is the evaluation of the model random forest. After the comparison, the logistic regressions achieved a modulo accuracy of 76%, but provided the highest recall for churn customer, which is the 52%, and making it the most effective model for identifying at-risk customer. While for the decision tree model, it's have the moderate accuracy like 80%, but show a reductions in churn recall to 42%. And for the random forest, it achieved a highest accuracy of 90%, but performed the worst in churn prediction, with a churn recall of only 19%. This comparison highlights that higher accuracy does not necessarily indicate better churn prediction performance. From a business perspective, logistic regression may be more suitable for churn analysis despite its lower accuracy, as it identifies a larger proportion of churn customer. With the result, the action can be taken by the organization is the personalized retention strategy, such as discount offer, loyalty rewards, or tailor marketing campaigns, or understanding past behavior and toward recommending concrete actions to reduce churn, and can be to maintain the regular model retraining and performance monitoring to ensure that the model remains effective.
This section translates our analytical findings into CEO-level recommendations. The goal is to provide prescriptive, data-driven actions that can improve marketing performance, customer engagement, and long-term business strategy. Our analysis showed that campaign type A generated the highest sales revenue, making it more effective than type B and C. Based on the finding, we recommend prioritizing marketing budgets toward high-performing campaigns like type A. This approach maximizes return on marketing investment by focusing resources on proven strategies. We found that this type of customer are the most responsive segment, contributing disproportionately to sales. Therefore, we recommend implementing personal-based and targeted marketing strategies for this high-value segment. This improves campaign precisions, increase customer lifetime value, and reduce waste marketing spend on low-response group. The results indicate that the staple products and coupon redemptions showing strong price sensitivity among customers. We recommend using these staple goods as promotional anchor to attract customers, while cross-selling higher margins or less frequently purchased products. This maintains strong sales volume while improving overall profitability. Our analysis showed that the campaign impact typically peaks on weekend, with a few days delay after launch. Based on this pattern, we recommend launching promotion early in the weeks. This allows customers time to plan their purchase and align promotional impact with peak weekend shopping behavior, improving effectiveness without additional costs. Based on the finding, we recommend deploying churn predictions module to proactively identify at-risk customer and target them with retention strategies such as personalized discounts or loyalty rewards. This shifts retention from reactive to proactive and reduce customer attritions. This project also demonstrates that successful analytics depend on data quality, tools, and skilled people. We recommend investing in stronger analytics capabilities by adopting robust platform, enforcing data governance, and developing analytical talent. This fosters a data-driven culture that supports continuous insight generations and long-term competitive advantage. In summary, our recommendation focus on targeted marketing by prioritizing high-return campaigns and high-value customers, optimizing timing and proactively managing customer churns, and investing in analytics capabilities. Together, these actions support more efficient operations, stronger customer relationship, and data-driven strategy growth. In conclusion, this project applies the full business analytics lifecycle to marketing data. We found that personalized campaign outperform generic promotions, staple products drive sales, and campaign impact peaks on weekends. Predictive analytics also enable proactive customer retention. Overall, this project highlights how business analytics supports smarter, evidence-based executing decisions and create strategy value for organizations. That's all. Thank you.